Hello render folks and welcome to my next tutorial. So we are here in Renderman and Houdini, and my today's topic is the LAMA shading network. So first of all, you will be able to follow this tutorial with the tutorial resources I will make available for free to download. So it contains the Pixar teapot. I just slightly modified the UVs, and you will also get the textures so you can follow it along. I'm just not sure yet where I will upload it, maybe on Gumroad for you with a discount code, or maybe on Google Drive or whatever. I will check that. So the link will be in the video description. So we will only do here this part. I will keep here displacement. I've made already a tutorial about how to make the displacement in Renderman. So it's just the usual procedure with the RGB layering system. So I want to keep the tutorial as short as possible, so we are not going to cover that here. Alright, so first of all, what is LAMA shading network and what is the difference to an Uber shader, for example? So we have here the LAMA surface node, which is kind of a bit the brain, how I like to call it, of the whole shading system. And then we have the Pixar surface shader. So what is now the difference? As you can see, the difference is we have on the Pixar surface shader, or for example also a V-Ray material or an AR standard surface from Arnold, we have usually here all these inputs. So we have diffuse and specular and fuzz and glass and all this fancy things within one node, which is cool. But to be honest, often you only use maybe 3 of them or maybe 4 of them, but the whole graph will contain all the info and all the data and code from all the other stuff that you don't need. So it's kind of a waste of stuff. While on the LAMA surface, we build this shader ourselves, but with that many diffuse layers as we need and that many specular layers as we need. So it's a bit more of a sandbox approach of building a material, and I really like that because it also offers a lot of flexibility. Okay, get rid of that. So let's go here through our first LAMA node, and as I said, this is kind of a bit the brain of the LAMA shading network, and the brain needs to be fed with data, and that's what we will do in just a bit. So on this node, we have here a few checkboxes we can check on or off, and that actually is to tell the engine, hey, what do you compute and what don't compute at all. So it actually brings in a bit of performance as well, so that's actually pretty cool. For our material, we want to create an interior because it's for glass. Then we want to create subsurface, and we also want to have the opacity because of a glass. So we don't need to compute presence because that's for an opacity map, for example, when you have a black and white mask to kind of cut out a leaf, for example. I'm talking about leaves. If you would make a leaf, then you can turn on two-sided, then you can feed in here both sides of the material, which is pretty nice. And here under utility, there's actually nothing. I'm not even sure why here this is where there's a drop down. Okay, so let's bring that here into our output, and we want to make our first material here. And to show you that how you can do that, we have a few bunch of nodes we need to introduce. For example, the LAMA diffuse. As I say, this is now dealing just with the diffuse part. We want to have the dielectric, and we want to use the layer. So there are actually different nodes you can use to mix and layer some components together. And the rule of thumb is a bit, if you layer things together, then you're using the LAMA layer. And if you mix certain materials, for example, near the metallic and the yellow subsurfacey part, there you will use a mix because they're just two independent materials. We want to mix in one material here, in one shader. While layering is more of when you have, for example, the base subsurface scatter stuff here, and you layer the specular component on top, or for example also dirt can be layered. All right, so let's bring in here our LAMA diffuse to our base, and we can bring the dielectric here to our top. And this is going into our brain, so we don't need the orange flags here. And since this is already pre-assigned to my teapot here, we can now hit the render button and see what we are getting. So sadly I cannot shift the whole scene because I'm using here the Cave Academy plinth, and I'm using an HDR from Cave Academy, so I cannot ship that sadly, so you have to use your own scene. And as we can see, we only have here now a gray material. So for example, if I just plug in here the diffuse, we can see we only have the diffuse component. And that's actually how we can create our materials. So we layer together the components we need. So when we have a look on the LAMA diffuse, so we have a whole bunch of different parameters like the color, we can even apply extra roughness for it, and the more advanced stuff here. On the LAMA dielectric, we have a few more, and I like to switch it here from artistic to scientific because this gives me the control that I know already, for example, from an Arnold shader. So we have here all the different extras you can tweak on this material layer, kind of. But I would say if you want to know in depth what they are doing, open the manuals from Renderman, the docs, and read through them. They're documented there. So as I said, I want to keep it a bit more straightforward here, that we can get a practical use of this system. So first of all, I don't want to have here diffuse because we are focusing first here on the yellow material. We want to have the subsurface scattering node. Well, let's hook that one up and kill diffuse. All right, so on the subsurface scattering, we have a few parameters we need to tweak. First of all, we need to tell the render engine how we measure all the units here, and I like to change that here to 0.01. So here the next one is the radius we want to tweak. So we can go here for this peach-like color we know, for example, from shading as a skin, probably something like that. We can maybe tweak it even more. It doesn't matter that much. You can go for values you like. So you can go even for blue if you like that. And then we have also under advanced a few settings, and we are interested in the albedo inversion method. I like to keep it on Chang. I find that it gives a slightly more realistic feel to it, but it can be just a me thing, but I like to change it here to Chang. And I also like to bring in a bit of anisotropy. So the anisotropy, as we know, it kind of directs the rays towards the camera or away from the camera, and I like to bring that in here a bit. So we can also change a bit the IOR if we like. I think that's all already looking pretty cool here, so we can isolate here one part to see what it's actually doing. Give me the Renderman, quick moment to load. All right, it looks pretty nice. So we want to bring in some data, right? Let's bring it over a bit so we don't have to get that much of a distance. I've here already preloaded my textures, which I said you can get for free as well in the resource files, and they're also pre-converted already to TX files, but I will also ship the raw ones. So we want to have here the diffuse color, so they're they're here stored. Let's grab here the spaghetti and bring it into the subsurface color, and we should get here this yellow looking teapot that looks a bit like a sponge material. So we can actually tweak here now a bit the scale, because I think right now it's a tiny bit deep, and we can change it with the scale. So the scale actually acts a bit like a multiplier for all the values here, for example, for the radius. And with that we can control how the material behaves. Then we also can bring into play here the roughness map, bring it into the roughness, and we should get more of a rougher material here. Actually, as you start to see, it's pretty easy. So I know a LAMA network can look a bit overwhelming because it becomes super big and everything is kind of connected together, but that's super easy. So we have the usual inputs like roughness, we have the colors, and we're doing nothing else. It's just an Enuber shader feeding in the different data into the layers. The only difference is we have it now made ourselves, our material, which just contains a dielectric component and a subsurface component without any other inputs. That's pretty nice actually. But let's say we also want to bring in a bit of bump details. How are we going to do that? So let's go in here for the Pixar bump node, and here we can feed into our bump map pattern input. And here we also have the normal inputs. So feed it in, here we go, and I think it will be a bit too big, so let's bring it down a bit. Probably something like that. I think for that material, it's already looking pretty good. If we have the feeling we want to still tweak it, then we still can go back and tweak it, so it's pretty nice so far. And I think we move on to the next material because, yeah, I don't want to overstretch here everything. And that's about the metal ring here. So to do that, we bring in first LAMA mix, because as I said previously, we want to mix here different materials together. Oh, I misclicked. LAMA mix. All right, this one is going on to the material 1, because we mix out the material 2. Then we can create first a conductor just to see what we get. Bring that here into our material 2. And I have made here a single texture which has channel packed masks. So in one channel there is one mask, and then in the other channels are other masks. And I forgot a tiny bit which one is in which one, so we have to find out now. I think that's the correct one. Pretty cool. So we are getting here now a gold material, which is the default for metal here in Renderman, but we can change that. So I also like to change it here most of the time to scientific, or yeah, it's just it depends a bit. If you feed in some texture data, then you can just leave it at artistic, because we have a cool node that we can use to change these values. Then we also have the usual values like the roughness. We can change the anisotropy. We have all this advanced stuff. But again, as I said, if you want to get to know a bit more about the values here, then just read the manual. But as I've created here these textures, I have made a bit more complex material, for example, metal base. Then we also have rust. And that means rust is not a conductor. For rust, we need to create a dielectric material as well. So that means we bring in another LAMA layer, because now we have to make the material for the rust. That means we need to diffuse, and we need the dielectric. So let's hook them all together. And then we bring in another mix for the metal, because we kind of want to, this is not, I mean, it is kind of layered. So the rust is kind of on top of the metal, but we want to have a clear cut between these two materials. That's why we want to use here another mix. I think technically you could use the layer, it would produce the same output, but the LAMA mix is way lighter in terms of how heavy the node is. Okay, so we need to feed that here with a few different things, and the first of all is here the metalness. With the metalness texture, actually, we mask out the metal part with the rust. So as we can see now, everything which is gold is now our conductor material, and everything which is the gray is the dielectric material, for example, the rust or the star I've entered here. All right, let's feed in here some data. First of all, let's bring in here the roughness, into the roughness again. Let's bring in here the color, diffuse color. Now we can see the actual color of it. It's pretty cool. And we also want to benefit here from the bump. Pixar bump. And the cool thing is, we can now control that independently. So you could use this bump here, but maybe you want to have a stronger bump on that material compared to what we want to have on that material. So we can just use here our own bump node for that. Bring it down. Bring in here a bit more node graph niceness. Is that a word? Real estate? I don't know. All right, so how can we deal now with the metallic workflow? That's actually pretty nice in Renderman. So you have the Pixar metallic workflow node that is doing a lot for you. So first of all, we want to bring in here the base color. That's this guy here. And then we want to bring in the metallic texture. Here we go. And now this result diffuse we can use here in the LAMA diffuse. And now we have to read here the result specular edge will go here to the edge color, of course, and this will be the face color, which is here named as reflectivity. And look what we get. So actually this node is doing everything for us. So it actually changes the color of our diffuse map. It changes the color of the metallic part. So pretty nice and smart little node. But we also want to have the bump information on the conductor, right? So let's bring it up here a bit and connect this guy here. And now we also have the bump information on the metallic part. As we can see here, it picks up some cool looking small details. We can also say, hey, that's not enough. We want to boost them a bit. It's pretty nice. I think you start understanding the power that we have here with the LAMA node system. So we build our own system to kind of rule them all. So the graph already starts looking a bit more complex, and it will become more. But you can think about them as individual materials. So we have here one material. This is the metal ring. Then we have here the skin material. And now we want to deal with the other materials as well. For example, here is plastic feet. So technically, we could make another output node and assign here this extra material to the geometry, because the feet, they are an extra geometry, so we could assign it just to them. But since I anyway had to make a mask, I thought, okay, come on, why not just pack the other channels as well with a mask, and let's do everything in one material. All right, I think you guessed it right. We need another mix. LAMA mix. Bring that in here again. Material 1. Can already bring in here the mask. I'm pretty sure it's in the green channel. Yes, look, it's becoming black. We can introduce here a new layer, LAMA layer, because we want to layer again the specular component together with the diffuse. So diffuse. So if you make a plastic, you can also use subsurface scattering, so to bring in a bit of this light penetration style, but we keep it simple for now and just bring in here a LAMA diffuse. And here again a LAMA dielectric. Bring them here again together. So as you see, I'm just repeating the same process again. So the only thing what makes LAMA a bit difficult is you have to understand a bit how materials are working, how does it say, how they work physically correct. And for example, in LAMA you can fuck it up fairly easy by layering weird things together. I mean, it can be an artistic thing and play around with it, why not? I mean, you could layer a conductor component over a subsurface scatter material, so it's absolutely possible, which is physically not really correct, but hey, maybe that's the look you're looking for. On LAMA, it's just a bit important to think about how to layer the things together, that they are the way how it would be in a physical manner. So yeah, that's a bit the difficulty. But as soon as you get the hang on it, it's actually pretty easy, and you will understand the strength of LAMA. So you can also make cool little presets. For example, in Houdini, I've made here my few presets. So here, for example, I have a base, which is the base gray, or I have here the JF skin, which already has cool values for making a realistic skin. So I think this should be possible to make in Maya and Blender and such as well, but I'm just not sure because I'm not a Blender user. So I mean, not that there's something wrong with being a Blender user. Don't get me wrong, please. All right, let's bring in here the red channel again into our bump map. Here we go. I think this will be too strong as well. Bring it down a bit. That's actually how you can do that stuff. And for the sake of completeness, now let's do here a glass material. So we actually did almost all of the materials. So there's only the emission one is missing, I guess. And yeah, fuzz is more of a specific layer of a reflection. So yeah, we covered all of them then, I guess. So I mean, you can check here. You have some different ones like the LAMA sheen. It's called, not fuzz sheen. Then you have the emission. Then there's also the translucent. So you can play around with them and explore them. It's actually pretty nice. Yeah, I wanted to bring in the dielectric because glass isn't a dielectric, and I'm pretty sure you guessed it right again. We need another mix node. The mask we need here is in the blue channel, and hook that guy up here to our dielectric. And look at that, we have a glass. It's that easy actually. So I haven't made a bump map for that, so it's actually the simplest material ever I've created. It's just a dielectric node. But you can play around here as well. So change it to scientific and go for different IORs. If you have a different kind of glass, for example, if you make a diamond or whatever, then you can feed in here the data you want. You can also change the dispersion. You can bring in some colors. For example, you have the transmission color. So we can go here for a red, and as we can see here, the reflection is still white, so we can actually tint the reflection as well if we want. Oh, that's actually, how can I close it now? Yeah, got it. So you can actually be creative here and make the material you want or the material you need for your purpose. And look, that's all. That's all. So we have here one material, we have here one material, here one material, and here one material. I mean, of course, depends on your asset, it can become quite complex, and it makes sense to work in a way that it's well structured and easy to understand. But as you can see, LAMA isn't that hard to get your head around, I think. It's just the easiest way to think is really you build your own Uber shader. So yeah, the Uber shaders, the Pixar surface. So if we compare it, so for example, it will be each of these materials will be like that. But with each of the materials, we have so many inputs we don't need them. And here with that approach, we really just have what we need, and this actually is quite handy. Cool. That's actually it, and I hope it was helpful for you. If you have still questions, then feel free to drop them in the comments. There's also a pretty nice Pixars Renderman Discord server. If you don't know it already, the people there are pretty nice and helpful, so feel free to ask there your questions. And if you have a specific wish about a topic I should cover, then hey, let me know in the comments as well. And we'll see you in the next video. Bye bye!